Hey guys, I'm Pat, and in this video I will be explaining raycasting in Roblox Studio. So, the first thing I want to go over is this little laser thing I kind of set up. I'm not going to go over too much how I made it exactly. These are just some normal parts, and then in each of these little red parts I have an attachment, which is just an instance, right? It's like this little green orb, and it allows you to set like a position that's relative to its parent, which would usually be a part. And then I have this beam inside of it, and I pretty much just made it red, gave it some light emission, and I went to the toolbox and I searched up beam, and I took this image and just pasted it into the texture, and it looks kind of like a laser, I guess. So what I want to do is detect that there's hit collision here, because this is actually a beam, right? And beams don't have touch defense, only parts. Not to mention, touch isn't the most reliable for hit detection, right? So, in order for me to make a reliable way of detecting this, what we could use is raycasting, which is actually kind of perfect for lasers, because lasers are usually very thin, and rays are also very thin when we cast them. If you think about math, usually you would think about, like in math, there would be a line segment, where a line segment has 2 points. So it'd start at point A and end at point B, but for a ray, you would think it starts at 1 point and it goes on infinitely in one direction. And in Roblox, a ray is actually not, or yeah, ray isn't really a ray as you would think it would be. It doesn't go on infinitely. It actually has a set distance that it travels, kind of like a line segment, really. But if it hits something, then it'll stop early. So it'll keep going until it reaches its destination, but if it hits something along the way, then it'll stop there. So it's good for something like a laser like this, because it will hit between the 2 points, but if it finds something along the way, then it'll stop there, right? So what we're going to do is we're going to make a script. I'm going to go ahead and name this part here, because this is going to be our primary part for the laser. So I'll just call it laser spawn. And I'll make a server script and server script storage, and we call this laser handler, and we're going to use run service for this. I don't believe I've gone over run service before, so I'm not going to go too in depth over it, but I will kind of explain the idea of how it works. So the way run service works is you can think of it as frames per second. So in a game, you'll think like you have frames per second, which is really how fast the game is running. The more frames per second, the faster the game will run, really, and the better it runs, right? So you can think of run service as a way of measuring each frame. So run service will fire, it has a few different events, but pretty much all events will fire every frame of the game, instead of something like task.wait where you have to wait like every second or something like that, where it's based off of time. This is more based off of every frame in the game. Now if it's in a server script though, it won't be affected by client's frames per second. So if your PC is running at 30 frames per second, the server might be running at 60 or a different speed. I'm not sure what rate it's normal for the server. I would assume it's normally 60, but that's just my guess. So what we're going to do is every frame is pretty much cast a ray, and something good to know about rays is they are actually not very resource intensive. A lot of people think if you run like more than 2 rays at a time, your PC will just like catch on fire or something, but that's not really true. Rays don't actually take up much resources, so you can fire really like a ton of them at once in a second, and you won't really cause any lag or anything like that. Nothing to worry about, right? So what we're going to do is we're going to need to get our starting position. So I'm going to actually get a variable for our starting point, or our starting part. I'm just going to call it origin part, and we'll reference it from the workspace. Laser spawn is its name, what we named it. And what we'll do is we'll make a variable called origin, and we'll make it equal to origin part's position. And what I'm actually going to do is I'm going to make sure all these are anchored, because I know I didn't anchor them. And I'm actually going to put them all in a folder, or we can actually group them. we could group them, sure. Group as a model. And what we'll call it is, we'll call it laser model. Now the reason I'm doing this is because when we cast a ray, there's a chance that, well, actually it will definitely happen. It will hit probably one of these parts in here, and we actually want to really ignore these parts. So the way I'm going to do that is I'm going to parent them all to one model. And the way rays work is that we can filter things by the descendant instances. And what that means is we can say, give it this model here, and it will ignore all the children of this model. It won't just ignore this model, it will ignore every child of the model, which makes it very easy since you don't have to add individual parts for it. You can add just like the parent, and it will ignore all the parts that are under that parent. So it's very useful for something like that. And not just that, but if we have a part underneath this part, then it would also ignore that part. So ignore pretty much everything underneath that parent, which is what a descendant is, right? And now what we need to do is get the direction we're going to use. So what we can do is we can use this part's look vector. This is laser spawn. So let me actually get an image real quick. Like this. I'm going to copy this asset ID. I'm going to put a decal into this. And good thing to know about decals is by default they will be on the front face, as you can see right here. So now I can just add a texture to this decal, and using that texture I can tell which side is the front. However, it's neon, so it's kind of hard to tell. I'm gonna make it smooth plastic real quick, and it looks like it might be backwards. I kind of chose a bad decal for this. Oh no, that's the front. So we're going to fix this real quick, and now I gotta kind of fix my attachment. Kind of like that. That's good enough. It's kind of crooked now, actually, but you know what? I don't care too much. It's a little bit better. Close enough. All right. So now we can see that that's clearly the front because we have a decal on the front of the part, and we can see the decal. So we're gonna remove that decal. We don't actually need it. It's just to kind of tell us which side is the front of the part, so we know which way it's looking. So what we can do is we can get the part's look vector, which is a property of C-frame. So if you don't know C-frame, very useful to know for raycasting. I just posted a video on it. I guess it was like recently, right? And what we're going to do is make a variable called direction. And we're going to take the origin part's look vector. So we'll do origin part.cFrame look vector. And this will give us its look vector. So that's pretty much the direction that it's looking in, which is a unit vector. So it has a magnitude of 1, or a length or distance of 1, okay? And what we can now do is we can multiply this by the distance we want it to travel, because what raycasting does is it takes a direction, but it also needs to know the distance. So it will also take the distance of the you know, whatever, how far you want it to travel in the direction. So it will take a unit vector, but if you give it a unit vector, it won't travel very far. So you have to multiply it by a bigger number to kind of tell it how far you want it to go. I was going to say something else, but I forgot what I was going to say, so it's not a big deal. Oh yeah, I should make this back to neon as well. There we go. So now we need to figure out the distance we want to travel. So we don't actually know the distance between there and there. So what we can do instead is I can label this part and we'll call it laser end. And what I'm actually going to have to do is fix this because I changed it to be in a model. So now we got laser spawn. And we're also going to need laser end equals workspace dot laser model.laser end. And what we can do now is we can get the distance between these two parts using magnitude. I went over magnitude in my touched event video, but I'll go over it here as well. So we'll make a variable called dist, which will just be short for distance. I can spell it out, distance. And we'll make it equal to our origin part's position, or we can actually just use origin because that's our origin part's position already. And minus laser end dot position, and then all we gotta do is dot magnitude. And what that will do is it will give us the distance between these two positions, and it will automatically absolute it, or I think that's how you would say, is give it an absolute value. So it will always be a positive number. Magnitude will always be positive, no matter what direction it was in or whatever, right? So what you do is you subtract the two vector 3's, and that will still give you a vector 3. So what you do is you use dot magnitude, and what magnitude does is it pretty much gives you the length or the distance of a vector 3. So that allows you to get the distance between these two vector 3's. And now what we can do is we can take our look vector down here and we can multiply it by our distance, because our distance is how far in studs we want it to travel. So we want to multiply our look vector by distance, which will give us how far we want our ray to travel. And now there's one more thing that we need to do, which is ignore a few parts. So obviously we want to ignore the parts inside this model so it doesn't hit any of those and mess up our collisions. So what we'll do is we'll make something called raycast params. So in order to do that, we just call the raycast params.new function, and we don't pass it any arguments, it doesn't need any. And then what we can do is do ray params, because that's the name of our raycast parameters that we named, and we can access its filter type property. So raycast params.new just pretty much creates a raycast parameters raycast params like object, which has like its own properties that we can use, like filter type, which is an enum. So enum.raycast filter type, which is the type of enum it is. And then we can either do blacklist, whitelist, exclude, or include. I don't know what exclude or include do. I have never really used them, but blacklist and whitelist are kind of self-explanatory. Blacklist will ignore the parts that it's given, and whitelist will only detect the parts that it's given. So we're going to use blacklist so we can ignore some parts. And then the last thing we need to do is give it our filter descendant instances, which is just a table of all the instance we want to filter the descendants of. So obviously we want to filter the descendants of the laser model. What I'm actually going to do is make a variable for a laser model. If you noticed, I'm actually using it multiple times in my script. So that's how you know it's a good time to make a variable for something, which will clean up your script a little bit better. And now all you gotta do is add that into our table here, which will pretty much tell it to ignore all the parts inside this model. If you don't know what a table is by now, you should probably know what a table is. I'm not going to explain it, sorry. And now what we're going to do is make a variable called cast, which will store the result of our raycast. And raycast is actually just a method of workspace that we can call. There's also ray.new, which is actually deprecated. Don't use that. Raycast is the newer method. Some videos might be using that, but this is the correct method to be using. And the first argument is the origin, so its starting position. And then the second argument is its direction, so what direction you want to travel, and the direction obviously will also be the distance. And then the last thing will be raycast params. Now you don't actually need to give it raycast parameters if you don't have anything you want to filter out, but if you do, you should add it as your third argument, because that's kind of the order it's in. And then what we can do is we can check to see if it hits something by just checking if cast is not nil. So I'm just doing if cast because that checks if it's not nil. You can also do if not cast equals nil, but that's kind of ugly and not needed. So I'm just going to do if cast. So if there is a result of our cast, what we can do is we can print the cast.instance. So the cast is actually kind of like its own object. It has a few properties. So as the instance property, which is pretty much the instance that it hit, so usually be a part. And then the position, which is the position that the ray hit the part at. Normal, which is the vector of the intersected face. I believe that's like the face that you hit. And then distance is just the distance the ray traveled. And material will automatically give you the material of the part that was hit, which is pretty useful as well. Material is good for something like, say you're making debris for like a spell, and you want to shoot a bunch of like rocks in the air or something that match the material that it hit, and then you would use like raycasting to get the material that it hit and kind of like, you know, shoot off some rocks using the same material, right? So we're just going to print the cast.instance so we know what it hit. So what I'm going to do is I'm going to open output now, and I'm going to go ahead and test the game. Lookvector. I didn't spell lookvector right. That's nice. I'm a pro scripter, guys, I swear. So lookvector. See, if I had tab there, it would have worked right, because I didn't reference my part right when I was trying to write that, so it kind of was weird. Anyways, so you can see my output is now empty. I'm going to clear it. And when I walk inside of it, you can see it immediately tells that I'm hitting something, and it keeps doing it because it's firing a raycast every frame. However, you can see there's absolutely no lag, no impact on performance at all. And every time I walk in between it, you can see it pretty much detects my collision. So if I wanted to, I could check to see if the hit part has a humanoid, or the hit part's parent has a humanoid in it, and if it does, we could do damage. Or we could say if it's something like an obby, then we could teleport the player back to their previous checkpoint or something like that, right? So that's pretty useful for that. But now say we don't actually know what direction we want to travel in. So say we have two parts and we want to fire a ray between two parts, but we don't actually know the distance or the position, or like we don't know which direction the other part is in, right? I kind of went over this in my C-frame video, but I didn't really go over like casting a ray between them, so I'm going to do that. So I have two anchored parts here, which I'm actually going to lower a little bit. And I'm going to call this one part 1, and then this one can be part 2. Or it could be part A, part B, you know, whatever. And what I'm going to do is I'm going to try and figure out how to get the direction that from this position to this position. So that way I could fire a ray between these two positions. This could be useful for something like if you wanted to cast a ray between like a player and where they're targeting, like with their mouse or something, or if they're dashing. Usually with dashing, like lookvector would be pretty useful, but you can also use this method for something like dashing to see if they're like gonna dash into a wall or something like that and prevent them from dashing into a wall. So anyways, I'm gonna make a new script now. I'm just gonna call this direction ray, I guess. Don't know what else to call it. So part 1 will be workspace.part 1, and then part 2 will be workspace.part 2, right? Now, what I'm going to do is I'm going to take part 1's position, which will be our origin. Part 1's position will be our origin, and then what we'll do is we're going to need to get our direction. So the way I'm going to do that is I'm actually going to use unit. So we went over magnitude, but we can also go over unit, and what unit does is it pretty much gives us a unit vector. So it'll take a vector 3 and it will take all the values and pretty much like floor them to a low number, so that way the vector 3 has a magnitude of 1. So that's what a unit vector is. It has a magnitude of 1, right? So it's very important this time actually which order you have the positions in. I'm pretty sure the origin goes last, so what you want to do is you give your first position that you kind of want to go to, the direction you want to go to, and then you give your starting position next. So it's very important which order you have your positions in here. For magnitude it doesn't matter, but for unit it does matter a lot. So we're going to use unit here, and now we'll pretty much turn it into a unit vector. But now you'll remember that we don't have the distance. I'm not actually going to get the distance here. I'm just going to multiply it by a big number and hope that it hits the other part, which is our goal here. And then all I'm going to do is I'm going to cast. We don't need raycast parameters here because there's nothing in between them that we really need to worry about, right? So workspace raycast, and then we're going to give it our origin and our direction. And then what we'll do is we'll just print the cast.instance, alright? And we'll go ahead and view the output when we test it. So I'll go ahead and run it. And you'll see we got part 2 in the output, which means that it worked just like we wanted it to. So that's a good way of getting like the direction between two parts, right? So that's really how raycasting works. Something to keep in mind is if you just use a normal vector 3 for the direction, it will use the world's direction in vector 3. So if you try, so Z won't always be forward for a part, and X won't always be forward for a part, depending on which way it's facing or whatever. If you just use a normal vector tree, but if you use like a parts look vector, or you use like unit, something like that, then you could use, then those values would be based off the part's direction or its orientation. So that's something to keep in mind. Now, what I'm going to do is I'm going to give you something to script. I have a little gun here, a very simple gun. Pretty much all you do is you click and it shoots, and if it hits something, it does damage. Alright, so we got a gun, very advanced model you see. I made this in Blender, I'm not gonna lie, pretty good looking. And whenever I click, you can see if I click a dummy, it does damage, but if I don't, it doesn't do damage. And even if I click myself, you can hear me clicking, it's not damaging me, but if I click the dummy, it damages the dummy, which is good, right? That's how we want it to work. So I advise you try and make it on your own, and I'll try and run over it real quick because I know this video is getting a little long, but I'll try and run over it and then explain it a little bit. So if you want a hint, here's kind of how the local script looks, which is really the big thing. You can use local player.getMouse, and then you can get the mouse's .hit, which is a C frame. And you can get the position. So C frame actually has a position property, and we can use that to get our mouse's 3D position. And all we do is we fire a remote to our server to tell the server, hey, we want to shoot a bullet, and we give it our position. Now you could do this on a client, however, I actually don't even think humanoid take damage will even work on the client. So really it's good to have it server sided, and I even have a debounce on the server to kind of prevent an exploiter from like spam triggering this, right? I also got my range variable defined up here. So if I wanted to change the range of my gun, it would be pretty easy. I just come into the script and change this value at the top, rather than trying to sort through all the code to try and find where I use the distance at, or the range. Then I get our barrel's position, which is just a barrel. I have two parts here, by the way, something I didn't go over, and I have a weld constraint connecting both of them. Since in a tool the parts can't be anchored, so if you want to have multiple parts for a tool, you have to weld them both together with the weld constraint. It's pretty simple how it works. Just part 0 and part 1 are the two parts you want to weld. It doesn't matter which one's which, just weld them both together, and it will pretty much keep two parts together even when they're unanchored, which is very useful for something like a tool, right? And then I get the direction using unit. So I used the mouse position and our origin position, which is our barrel, and then I just multiply it by the range I wanted to travel. And then I use raycast parameters to filter out the player's character and the tool, since we want to ignore the barrel, the handle, and the character. So we get the character from our on-server event using player.character, and the tool is obviously just the script's parent, because whenever the tool is equipped, the script's parent should be the tool. However, there is a chance maybe that they unequip the tool super fast after clicking and it might error. So that is something that you could probably add a check for to make sure that this tool is equipped. You could make sure the tool's parent .parent is a character or a model if you want something like that. And then all I do is I just cast array. I check to see if there is a cast result, and if there is, what I do is I check to cast.instance, and I see if I can find an ancestor, which is a model. So find first ancestor, pretty much what it does is it finds the first ancestor, right? And which is a finds the first ancestor which matches the class name that it's given. So we're obviously doing model here, and then if you know, every character in the game is a model. So what we're doing is we're checking to see find the first ancestor, which is a model. Obviously you could use just like .parent here, but if say it's like a hat that it hit, like it hit a player's hat, then it could honestly, it could cause a problem because the parent of the part won't be the character, it will actually be the accessory. So using find first ancestor, which is a model, is a little bit better way of finding the character. And then we just check to see if there's a humanoid, because we don't know 100% certainty that this is actually a character yet, because it could just be a model, right? So what we do is we use find first child to see if the model has a humanoid in it, and if it does, then we deal damage to the humanoid. And then I just have a task that wait down here for our debounce, right? So that's really how the gun works. It's not too complicated. Hopefully everything in this video made sense. It was a little rushed, but I kind of had a lot to go over in this video. Hopefully this was helpful in learning raycasting, and thanks for watching.